Hello and welcome to the section 3.3 lecture today for Algebra 1 Part 2. Today we're going to be looking at area and perimeter of regular polygons. Okay, this is a pretty key point in geometry, is to be able to find the area and perimeter of these, and a little bit harder than what we've dealt with already. So let's go ahead and jump right in and get started. For starters, we want a couple definitions. First is just what a regular polygon is. Okay, it's going to be a, say, an n-sided figure where all n sides are the same length and all angles, I don't know what I was trying to do there, all angles are the same size. Okay, and so what that means for us really in math terms, we would say that all n sides are congruent and all the angles are congruent as well. So it builds these kind of perfect polygons. You know, an easy example is a square is a regular polygon. Okay, it's a regular four-sided shape where all four sides are the same length and all the angles are congruent. In a square, all the angles are right angles. Okay, so they're all the same. Another definition that we have is an apothem. The apothem is a line segment from the center of a regular polygon that goes, we'll say that it goes to I'm going to say to perpendicular to a side. And we'll look at what that looks like once we get there, but we won't see it right off the bat. For the perimeter of a regular polygon, since every side is the same, then the perimeter is going to be equal to a side length. I'm actually going to write it out instead of trying to use letters. It's going to be equal to the side length times the number of sides. Okay, like if you have a square, that's going to be four sides. So on this first one, we have a hexagon. That's six sides. They're all 3 miles in length. All right, so this is 3 miles, this is 3 miles, this is. They're all 3 miles. So for perimeter, we're just going to say, instead of adding 3 that many times, I have to count how many sides there are anyways. So we might as well use multiplication. 3 times 6, we have 18 miles. That is my perimeter. The next one kind of looks like a stop sign. That'd be an octagon. So there's 8 sides, and they're all 15 centimeters. So the perimeter is going to be 8 times 15. It's 80 and 40, so 120 centimeters. The last one we have, better count these sides. It looks like an odd number. You can tell that because on one top or bottom, you have something that's flat, and on the other, you have a point. So let's go ahead and count, starting with this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 sides. We'd call that a nonagon. So my perimeter is going to be 9 times 3.5. And just to double check, 31.5. And those are inches. Remember, perimeter is a linear measurement, so we do not have squared on our units. It's just linear units. Let's take a look at area. So a very useful fact is that all regular polygons can be inscribed in a circle. I'll get to why that's useful in a little bit. So if we're looking at this, okay, I have a circle that goes around a pentagon. Okay, so there's 5 sides. And if we find the center of that circle, so the reason that it's useful that this fits in here is that all of these lengths are actually the same because they're all a radius of the same circle. And any radius in a same circle is congruent to any other radius in the same circle. Okay. What that gives us, we're not going to use that very often, but what that gives us is that all 5 of these smaller triangles in here are all the same. All these triangles are the same size. So let's think about how we're going to find the area, but let's find the area of just one of these triangles. Let's pick on the bottom one. So in order to know the area, I need to know what the base is. So let's think about this. So the area is going to be made up of these 5 triangles. And those are all the same size. So let's try to find the area of one of them. Well, we need the base. So the area of a triangle is 1/2 times the base times the height. Let's first look at the base. What is the base of this triangle? If I knew this height, there's a great straight line there, then this would be my base. Okay, well, if this is my base, this is a side of the shape. So we're going to have 5 times 1/2 times the side length okay, and then we're going to need something for the height. Well, this is where that other definition comes into play. I'm so glad I can talk today. This line right here, this height, is the apothem. Okay, so that line is the apothem. Okay, and so that's going to give me my area. Let's see if we can kind of move some things around a little bit, which we can because this is all multiplication. Even though it looks like, well, you might have to use distributive property with that 5. You don't, because everything in here is multiplication. So I have 5 times 1/2 times side length, let's call that S, and let's call the apothem A. Let's move these things around a little bit. I'm going to say 5 times s. Actually, I'm going to go the other way. Kind of. I'm going to bring the 1/2 in front. And apothem there. Well, in this picture, and this one is unique because we have 5 triangles. We're not always going to have 5 triangles. What is 5 times s? If this number right down here is s, what's this multiplied by 5? We just did it. It's the perimeter. So 5s can be seen as the perimeter, and this is going to give us our area formula. We're going to write it a little bit differently, but for any regular polygon, the area is going to be 1/2 times the apothem times the perimeter. So 1/2 AP. So you can see that finding the perimeter of a shape is going to almost be required to find its area. And it's going to happen every time that the number of sides we have is going to dictate the number of triangles that we have, because it wouldn't make sense like to not have this line right here, because then you'd have this shape, right? And I don't know a really good way of finding area of that. That's actually a kite. Okay, so I wouldn't have a great way to find the area of that without knowing some more information. We could, but if we make sure that we have all of our lines in there from our center to all of our vertices, then it comes pretty quick and easy. Okay, let's give some of these types of problems a shot. The first thing I want to do is to split each one of these regular polygons into triangles. Okay, this is called a triangle decomposition. So I'm going to use a straight line just because I can, and it looks a little bit better. Every one of these points here given to me is the center of that circle that went around it. So that means whenever I draw a line from here to one of the vertices, then it's all these lines are going to be the same length. So for this one, I just want to draw these 3 lines. Let me bump that one over a little. There we go. So there we see we had a triangle, and we split it up into 3 triangles. Might seem kind of ridiculous, but it's useful. Okay, this one, we have an octagon, and so we're going to be drawing a lot of lines. Do the best you can. Notice that I'm not doing 100% accurate, and I have a straight line tool. So I should be doing better. But I'm trying not to make this take forever, because we're not really doing any problems right now. Okay, but we want to kind of pinwheel all of our shapes when we're doing this. Okay, that's an important step, because it tells you how many triangles there are. Okay, but if we use our formula, we don't need it. Okay, that's the beauty of it. That's the beauty of having the formula in general, is that knowing that this area is just going to be 1/2 apothem times perimeter, the only work that I have to do is to find the perimeter and then do some calculations. So it's going to be 1/2. My apothem is 13.9. And my perimeter is just 11.5 times 8. Which is 92. So the area of this shape, 0.5 times 13.9 times 92, 639.4. And I guess they didn't give us any units, so we'll just say units squared, whatever the units might be. Okay, next one, let's go ahead and find perimeter first, since I need it. It's going to be 7.8 times the number of sides. Let's start on this one. So this is 1, 2, 3, 4, 5, 6, 7. 7 sides. 7 times 7.8, 54.6. So my area, being 1/2 apothem times perimeter, is going to be 1/2 8.1 times 54.6. $221.13. And again, units squared. We are again trying to figure out how many little squares would fit into this shape. I don't know. I could think of another way to do a problem like this, but this way works out actually quicker. My way would involve that Pythagorean theorem and splitting that in half to put it here, and it would get ugly, but I'll bet we'd come up with the same thing. So finding our perimeter, it's a triangle, so we want 20.8 times 3, 60 something, 62.4. So the area is going to be 1/2. The apothem is 6. Perimeter is 62.4. So 0.5, not 0.2. 6 times 62.4. 187.2. Units squared. Next one's a pentagon, so there's 5 sides. We have 12.9 times 5. 64.5. Okay, so our area is going to be 1/2. 8.9 times 64.5. And we get 287.025, and those will be units squared. All right. So you can see once you know those things, it's not that tough of a task. The calculations are pretty quick and easy. I would recommend having a calculator when you're trying to do it though. Anyways, I hope you have a great day. Make sure you get any questions that you have over on the left side. Summarize your notes. Have a great day, and we will see you in class.